Well, here's a good challenge. An old Farfisa, I don't know what you would say, but customer has a broken key on it. And luckily, I was able to actually take another key out to actually use as a reference. And I'm going to see if I can make a new key. I've done this before out of wood by hand, which was very tedious, but this time I'm going to try to model this in 3D modeling, see if I can 3D print it, find the paint, and try to either find the filament in the right color or find the paint. If I can't do that, it might be very hard to find the right filament because it's not white. It's like bone, ivory color, and it's also faded from the, I think this is probably a 70s or 60s keyboard. So it's very faded as well, sun faded, so it's sort of yellow. So very difficult. I have to actually mix up and match the color if I want to do that. But let's see how we go first. Let's see if I can actually make this somewhat complex shape with hollowed sections and stuff. See if we can actually make that work. I'm going to use 3 bits of software to do this, and one of my favorites by far is eMachine Shop. One of the best modeling programs ever, in my opinion, for making mechanical parts. It's free. Just go to eMachine Shop, the website version, and they have a live CAD, computer-aided design package, and it has a tracing paper function. So all I did was I took a photo of the key lying on its side and with my phone directly over the top, and then you just bring it in to the tracing paper mode in eMachine Shop, and then I just made my shape around it, like basically just created lines and created a template for it. And then from there, you can actually extrude it to 12 millimeters wide, which is what I need to do, and then just export it up here, export as an STL file. And from there, I can then bring it into my next favorite program, which is Tinkercad. Again, another free online, fantastic program. And let's put it in there and then extrude it and create the other bits. It's so easy. All right, so another genius program that I absolutely love. It's so much faster than Fusion and everything else. I just hate all those programs. They're just so horribly outdated and slow. This is just brilliant. Just from up here, I just went import, chose the STL file, brought it in, directly comes on the screen, and then I just, was already extruded, and it was basically a solid STL object. So then what I did was I flipped it over like this, and all I did was dropped one of these, which is basically a hole cutting tool, down onto it like that, stretched it out to the size that I want, and then lower it down into the actual object like this, and then you just highlight it and you just go combine it as one item up there, and it's a hole cutter and it cuts the center out. So that's what I've done. I've got my key and I put some extra parts on it, like this top cone here. So I just measured the previous key and just dragged the components on. Even dropped a hole cutting tool down into here to sort of clear out this section as well. And yeah, it's all size accurate. Fix the end section up here as well. Cut a little keyhole there for the spring to come through. And that's my key. And then you just highlight the whole thing. It's really easy. Select all, and then up here, export as an STL, or you can export it as an object file or a GLB or a Fusion file for getting totally confused. I hate Fusion. It's just so antiquated. I hate it. But I love click and drag of Tinkercad. It's just, for me, it's the way my brain works. It's just so much easier. Export it as an STL. And then we go into my next favorite program, Cura. And inside there, we just basically drag and drop it onto the screen. I chose PET G filament and printed the puppy out. And then, so here it is. Pretty cool. Here was print attempt number 1. I wasn't quite happy with it because if you see here, where it actually slots in here, this pivot point here wasn't quite wide enough. So it didn't have the range of the other one. So I went back into my modeler and basically made that center section longer. Obviously I'll have to actually take the peg out of the broken one, put it into position there. But it was pretty good. Close profile and stuff like that. I don't think I'll change that. That'll work. I've already tried to put it in the keyboard and it fits. It just didn't quite move the same way as the real one. So I'll do another go. It takes about 2 hours to print one, but I just sort of stick it on overnight and off it goes. It only uses about, I think it was 60 grams or something like that of filament. So we'll try again. But I'm pretty happy with that, considering it's the first key I've tried to make on the 3D printer. It's definitely the way to do it. Well, here's the final key. It's pretty good. The shape of it's good. Color is not quite exactly right, but I think once it's in the keyboard, it will work. It's as close as I can get it without actually mixing up a custom paint, which I really couldn't find the individual paints anyway. So this was just an ivory colored paint that I found at the local sort of hardware store, and hopefully that does the job. Inside a Farfisa. So very simple power board that has the amplifiers, audio amplifier as well. Speaker is attached to the headphone jack, and the way that works is, I don't know whether you can see it in there, but it has a switch. Basically, when you plug the headphones in, it switches off the speaker. When you unplug it, it shorts out the headphones and sends the signal down the grey lead to the speaker. So what that means is that when you plug stereo headphones in, you only hear it in one ear. So it's designed for people with one ear. Working, not perfect, but I put it down the bottom so you can sort of hide it a bit, but it triggers perfectly. It's still a bit noisy, so I'm going to work on this, see if I can improve it. It's part of the circuit design. They weren't great at the time, but I'll see if I can make it better. Here's the key that I made. You can see I didn't worry about making this top part of the key because it's just not necessary, because you only see it from there anyway. But yeah, it's working. So next job is just to make this a bit quieter. So these capacitors are dead, and replace these. That'll get rid of some of the hum. The trim pot, cranked it all the way up to maximum so we get best signal to noise. And we'll see how that works.